Good day, my dear students, and welcome back again here in our chemistry class. And for today's video, I'll be discussing classifications of matter. So there are materials that are pure in terms of its composition, like water. Others are a combination of two or more substances, just like in our atmosphere, which is made up of different gases. The question here is, how can matter be classified? So matter can be classified as either solid, liquid, or gas. And under by matter, they're also being classified by their properties. So in our previous video, I discussed the physical properties and the chemical properties. And just to give you a review, again, the physical properties is a matter that be observable even without changing the composition of its matter. It's either color, size, or shape. For the chemical properties, it has been observed, and once a material undergoes a chemical reaction, such as flammability, reactivity, or biodegradability, definitely can be defined as chemical properties or chemical change. Now, under the matter, we have the different composition, which we have pure substances and mixtures. Where in the pure substances, matter have fixed or definite composition, and mixtures is a combination of two or more substances. Now, the pure substances, we have here the elements. The elements are the simplest form of matter made up of only one kind of atom, and elements of different kinds also differ in the atoms that make them up. So, examples of the elements are copper, iron, lithium, sodium, so on and so forth, which you can see definitely on the periodic table. Now, element cannot be decomposed into simpler forms by physical or chemical means and react with one another to form new substances. Under the periodic table, we have 118 elements known to exist arranged in the periodic table. Now, 94 of these are naturally occurring and 24 of these are synthetic. How are chemical symbols written for elements? Definitely, the chemical symbol for elements has a symbol that's used around the world. Symbols for elements may have one letter or two. Example, the first letter of the common name of the element, we have the hydrogen, which is H, boron, B, and carbon is C. For the two letters with a common name, we have the helium, which is He, lithium as Li, and cobalt as Co. For their Latin names, such as antimony, we have the symbol of Sb, and in the Latin name is tibium. For copper, the symbol is Cu. The Latin name is cuprum. For gold, we have the symbol of Au, and the Latin name is aurum. Now, here's the example of our periodic table. So as you can see, the elements are arranged based on their groups and based on their periods. Now, all known elements according to their chemical properties. So they are divided based also on their properties such as metal, non-metal, and the metalloids. Now, in the periodic table of elements, a list of all elements in a tabulated form are arranged in such a manner so that elements with similar properties are close together. And each entry symbol of element plus their name, atomic number, plus atomic mass. For example, we have here the element. Example is H as our symbol of element. And then for the name, that is hydrogen. For atomic number, definitely we see here as 1. And for the atomic mass, definitely it is written here 1.001. So that's how you read and understanding the parts of a certain element in a periodic table. In addition to this, elements are arranged in rows and columns. So the columns is in groups and rows are in periods. And with similar properties are arranged in the same group, again, they can be differentiated as either metal, non-metal, or the metalloids. So here is the example of a periodic table. As you can see, they are arranged by its period and groups. So as I said, in the periodic table shows the division of elements to metals, non-metals, and metalloids. The good thing here in the periodic table is, as you see it in a physical copy, or here in a digital copy, you can see that they are identified based on their color, or they're categorized using the different colors. So for example, for you to easily identify which is the metals, definitely that's color green. For this kind of red or kind of peach color, that's considered as metalloids, and for the blue one, that is the non-metals. Now, the purpose of using periodic tables is a very useful tool that can help in identifying elements that exhibit similar properties. Now, as they being classified with the three categories such as metals, which is the leftmost of the periodic table, non-metals, which is the rightmost of the periodic table, and metalloids is the staircase like between metals and non-metals. How can elements be broken down into much simpler forms? So first, we need to know the different elements categories, such as this one, the compounds. Compounds is composed of two or more different elements that are combined in a fixed ratio by a chemical reaction. For example, H2O. And they are formed when two hydrogen atoms combine with one oxygen atom. They're considered as compound, containing two or more different elements. Now, many compounds are found in the environment. For example, the carbon dioxide, we have the sugar, we have the dioxide, water, so on and so forth. Now, some compounds are formed when an element reacts with another element, and some compounds are products of chemical reaction between two or more compounds. For example, in the cellular respiration, as you undergo a photosynthesis and how the certain plant release its oxygen. The properties of elements make up a compound which are different from the properties of the another compound. For example, sodium chloride or table salt in a layman's term. So there is composed of one sodium atom and one chlorine atom. Its constituent elements are harmful and toxic. Now, may be classified according to the specific elements present, such as organic compounds. These contain carbon and hydrogen. For example, carbohydrates, proteins, lipids, and fats, so on and so forth. So they're considered as organic compounds. Again, the keyword here in the organic compounds, they contain carbon and hydrogen. For the inorganic, they do not contain carbon-hydrogen bonds. For example, carbon dioxide, we have the water, table salt, which is the sodium chloride. Okay. Now, as you can see here, in organic compounds, the hydrogen and carbon are not combined. That's the whole picture. If I'm going to illustrate here in the organic compound, what I'm trying to say here is there is a chain of carbon. For example, we have the CH4 carbon, and then we have hydrogen, hydrogen, and then hydrogen. This refers as organic compound. For an inorganic compound, if you're going to observe here, there is no presence of carbon and hydrogen bonding. So for example, we have here the H2O, so we have O and then we have the H. For sodium chloride, we have the Na or the sodium and the chlorine. And then for the CO2, we have here the oxygen, carbon, and then oxygen. So there is no presence of carbon and hydrogen bonding. How are compounds formed? So they undergo a chemical reactions where it is one of a process of creating compounds, such as chemical change. This results in the formation of a new substance or a product with a different identity from the elements or compounds that constitute its reactants. So the kinds of chemical reaction can be defined as exothermic or endothermic. Exothermic is a reaction that gives off heat or a combustion reaction. Okay? Which exothermic heat, again, it gives up heat. For endothermic, it's a chemical reaction that absorbs heat as it occurs, allowing it to produce new compounds, such as photosynthesis. To make it more simpler, for the exothermic reaction, there is a release of heat. Releasing of heat, that's exothermic. For the endothermic, absorbing the heat. So there is an accepting and rejecting. How are compounds categorized? Now, compounds can be categorized based on the presence of the elements carbon, organic, or inorganic. This may be categorized based on the type of bonding, is either ionic or covalent bonding. Again, when you say bonding, composition of two or more elements. Now, under the compounds, we need to categorize it as either organic and or inorganic. Now, its constituent elements can be also defined as ionic or covalent. So when you say organic compounds, they are compounds in which one or more carbon atoms are bonded to other elements, and most commonly hydrogen, oxygen, or nitrogen. Now, all living things are composed of organic compounds such as plant, human, or let's say any living things considered as composed of organic compounds. For the inorganic, a class of compounds lacking carbon-hydrogen bonds, which everything else except carbon. Now, it comprises most of the Earth's crust, and definitely when you say inorganic, most likely it revolves with the non-living matter. To make it more to make it simpler, we have there the different properties, and we categorize it as either organic or inorganic compounds. First, we have the composition, which contains carbon and hydrogen for the organic and no carbon and hydrogen bond in inorganic. For solubility, for the organic, it's insoluble. For inorganic, is soluble. For the flammability, for the organic, is flammable. Inorganic, low flammability. For the conductivity, for the organic, poor conductor, non-electrolyte. Inorganic, conductor, and electrolyte. For the boiling point, organic has a low boiling point. Inorganic has a high boiling point. For the melting point, organic has a low melting point, and for the inorganic has a high melting point. Now let's move here in the compounds. So we have first the ionic compounds. Here in the compounds, it exhibits ionic bonding. When the electron transfer made up of positively charged species such as cations bonded to negatively charged species such as anions. If you will observe here on the right side, the sodium chloride is an ionic compound made up of sodium, which is ion, and chloride as an ion. So there, as you can see here, sodium chloride are considered as ionic compounds. For the covalent, compounds that exhibit covalent bonding, which means electron sharing. So this carbon monoxide and carbon dioxide are considered as covalent compounds because carbon atoms are covalently linked to oxygen atoms. To make it simpler, ionic compounds is a combination or a bonding of an element between metal, and non-metal. That's the key word. For the covalent bond, to make it simpler, this is a bonding of both non-metal. So in your periodic table, you can easily identify the categories. Where are the metals and where are the non-metals. Now, there will be also another discussion regarding on this one, because I'll be discussing also the periodic trends, where you will now create your own elements, how you're going to combine them. But for this video, I'll be focusing first on their definitions. How are chemical symbols written for compounds? So they are represented by chemical formula, where a combination of chemical symbols of elements that constitute a compound. For example, sodium chloride has a chemical formula of sodium, or NaCl. The ratio is 1:1 of Na and Cl. Carbon dioxide has a chemical formula of CO2, where the ratio is 1:2 ratio of C and O. So, for you to get the ratio on this one, you simply look on the subscript. The subscript here is here, under the atomic element. Now, always remember that if you didn't see any number on a certain element, under the element, on the subscript, definitely we show that there is a 1 in there. Now, the subscript indicates the number of atoms of a given element. Now you're able to understand the different compounds such as ionic and covalent, and you're able to know how to get the ratio of a certain compound. I'll be ending my lesson here, and for our next video, I'll be discussing the electronegativity and the different types of bonding. So thank you so much, and hope to see you again in my next video. If you have concerns or you need clarification, you need to take a screenshot of any of these frames and you can directly message me.